right, so let's start building the extra splashes around the boat, because if we look to the boat and the simulation at this stage, let me see if I can find it. For example, around here that the boat splashes against this wave, you see it's missing like a lot of things. You see this big movement on the water, but it's lacking a lot of splashes around this area and so on. So what I want to do is to do a customizable, and it's always better to get the main flip and then to add additional splashes afterwards. Otherwise, if you want to achieve additional splashes in the main scene like that, you probably need to increase a lot the dynamics of the ocean itself and the velocities of your collision object. And for that, you also, like, unintentionally, it would result in artifacts and maybe like splashes where it shouldn't have, like. So just use regular velocities on your main object for the first pass, and then work on top of that for later iterations like we're going to do here. And you see that we're going to have a lot of control over this technique that we're going to have to use. Okay, so let's come to the whitewater tab, and I want to do an object merge. And for now, let's merge the ocean. So the render, this deal, the one that we're looking at. So I'm going to see here. Also, I want the boat itself, so we can get the distance. So another object merge. Let's call this flip geo in, and here sailboat in. Okay, let's go. Let's grab our sailboat. The sailboat for now can be the render one, or yeah, this one is good enough. So yeah, this guy here. Yeah, this is what we need. So actually, we can just do a blast and get only the hull for that, I guess. Yeah, we can work just with the hull for what we want now. Okay, now that we have the hull and we have the flip, we can do a point swap. And my idea is to get the distance from the hull to the ocean, and create like an emission area for that. Okay, so that's the idea behind we're going to do. And let's say set emit area. All right. First, we can just grab the XYZ distance. So we're just taking the distance from the geometry to here. So it's from the second input, and we want to grab the position of the second input. And then we fit range that distance. I want to fit range it, like, let me just visualize in color. Right, so here you can see. But what I want to do is like from 0.3 to 0.5. So from 30 to 50 centimeters away, I want to invert. So I want to have like this area. But I also want to break up that with a noise. So let's create a turbulent noise. Otherwise, the emission is going to be very flat and linear, and you could tell. So let's grab the position. I want to promote this offset parameter so we can animate this. And let's visualize also that in here in the color. Okay. I think it can be the alligator noise, maybe 1.4, something like that, a little bit more frequent. And then I want to add a fit range. And let's do like from this 2.4 just to increase a little bit the contrast. And then we can multiply that. So let's multiply and let's visualize that in the color. Great. So here is our multiplication. Awesome. And then let's delete. I think, yeah, let's do something. Let's delete because we have like so much attributes here, and I just want to keep the color. I don't want velocities. I don't want anything else. Actually, you can keep the velocities. Yeah, it could be good to have the velocities. So yeah, we can use that. But I might not want to use this because the reason is that like sometimes here the speed of this is going here, and I want them to just splash away from the boat even from this distance. Okay, so yeah, I'm not going to keep that, so I'm going to keep only the color. And yeah, let me disable that. So now what we can do, we can place like a scatter node. The density can be the CG attribute. So based on CG, we can scatter. We can go like 150,000. And there's two ways of doing that. I also want to disable the relaxed iteration because we can, as we want more or less this amount, we can also just come in here, and instead of doing that, that's going to always keep like this. We can also disable this, and then here we can just add until you get roughly the same. So maybe this, yeah, this is a bit more, so maybe 7. Yeah, we have like a little bit of variation regarding the amount based on how much water we have around the boat itself. So here comes back to 80. But yeah, I want, oh sorry, I want to keep the count in here. So because sometimes we have like areas that we wouldn't get a lot of contact, but it's the key part to get a lot of splash. So yeah, I'll keep like that. So I want to delete any particle that's inside our boat. So I'm going to create a copy of that, but instead of grabbing the geo, I want to grab the VGB, and we can just maybe, yeah, we might need to dilate it a little bit or not. Let me see how much we can get. So I'm going to plug this in here, select, and we want to get points and by volume, right? Like, so this is a VDB. So all these are going to be deleted. I think it's good. We don't need to increase. Let's call the name of the group group inside, and let's do a blast, and let's delete from group inside. Yeah, no, it's good. What we can now add the velocity. I want to have like just some initial velocity to it. We're going to do the velocity in 3 stages. So the first stage, we're going to add initial velocities to it. That is going to define how much we want the velocities to be in the main direction. So we can use the point velocity. And instead of computing, otherwise it's going to compute from the formation, I want to keep incoming. I want to add velocity, and I want this to be 3.5. So now every point has a vertical velocity on y, just pushing upward. And then what I want to do is something like, we have the boat, the hull of the boat, right? And then from the hull of the boat, we can extract the normals of it. And we can add the normal of the boat that is perpendicular to the primitives on the side of the boat, or to the points, or to the vertex. So it's going to push it outward. And that's how the splash should go up and out, right? Like that's the how the splash should behave. Let's get the normal for that. And here you can visualize we have the normals, and let's transfer that as the velocities. But if the velocity is going down, I don't want the normal is going down. I don't want to add low like a negative y velocity to the splash. It doesn't make sense that the splash burns already under the water. So we want at every single splash to go at least like a positive y, you know. And but the most important aspect from this I want is to grab the normals, because then my splash can go up and push to the sides by the normal. So let's do that. I'm going to make like a point pop, and I want to just, we can add this later, but for now I want to set v by n. Let's plug this guy in here. So the normal I want to recompute in points just to be a little bit more accurate. And let's dive inside. So let's use the PC Open again. Remember that the PC Open allows us to make each particle look around itself and do additional like commands to it afterwards, like to search for an attribute, a specific attribute, or the distance or whatever. So I can just use that, and then from the second input is the file, and I want to grab the P as the position, and I also want to grab the normal. The PC filter. PC filter, yeah, this one. The PC filter allows us to grab the normal or whatever attribute that we want to filter. So in this, based on the search radius of 10 centimeters and looking to 10 points, is averaging the attribute that we defined here into the points. In this case, remember that we set the XYZ distance to 0.5 maximum. So I want to increase that to 0.5. And now if we visualize it into the normal, we have the normals in each point. That's exactly what we want. But as we mentioned, we want to do a couple of things for that. First, I want to do a vector to float and a float to vector. And I want to compare, I want to just grab this and let's compare if the y-axis, so now it's breaking the vector into three floats, x, y, and z. I want to compare if the y-axis is less than 0. What it means, like the positive is going up, negative is going down. I want to see if it's less than 0. And if it's less than 0, I want to not add any velocity to it. So I want to just do that. So we're copying that. And I want to keep the x. I want to keep the z. But I want to do a switch. The switch allows us to choose one or the other input. So this input, or a constant that is 0 in this case, 0. And what's going to define is the switcher, and the switcher is that. What it means is like output last input value. So the last input value in this case is the 0. So if it's less than 0, it's going to give us 0 positive y. Otherwise, it's going to give us the regular y that we are receiving from that. That is, it's okay. Most of it is going to be like just this area are going positive, but we are more concerned with the x and the y that we want to grab from the whole of the boat. What we can do now, we can, just to have like an extra control, we can do a multiply here. And I want to multiply that by mulch, so we can control a little bit how much velocities we want. And I want to now add this to our velocity. Okay, so add this to the velocity, and this is the new velocity, not the normal. So let's check what we have here. I want to get the velocities again. And I'm not seeing it. Why is that? Let me see why I'm not getting it. We should have like the velocity reading here. If I grab from this guy straight into the V, we have. So we see the velocities there. Okay, I know why. It's nowhere. It's just because we have this multiply, and by default it's set to 0. So if I set this to 1, we're starting to have something. If I set it to 5, we're getting a lot from it. You see how far the velocities are pushing away in these areas. And now it's just about controlling how much we want. And then after this, I just want to add like another point velocity node. But this time it's just because the point velocity have like some curl noise to it, so we can use this, and we can keep incoming. We're not going to add anything, just the noise. Okay, so we're going to add just the curl noise. Let's select. I want to get like a 1.5 and maybe like a little bit bigger, and we keep everything as is. So we just break up a little bit the velocities here. Awesome. Now let's think about the multiplication. For now we have like 3, and as I mentioned, I want it to be like very splashy, so maybe 3.5. It's a good amount. So we have like all this going. We can define that in here, but what I feel like is that to be able to get like a real good amount of splashes that looks natural and you emphasize some areas, it's good if you do like a flip book with just the ocean and the boat, because then you can just look to the moments that you might want to increase the velocity for a big splash, and some that you want to just keep like the normal velocities. That's just some refinery, and we're going to do that in the next lesson. Thank you. So here's my flipbook just to show you what I mean. I forget here to add the frame that I want, and that's key. You should see the frame. But basically, this moment where it enters the wave here, I want it to get like a big splash. You like the sound effect, right? Like, okay. So then here I want like a big splash when it comes down again, and then again here. So just the beginning in this area, we don't want like a little bit of splash, and this is frame 110 in my case. So let me just grab that. Where is it? Is here. All right. So we can play with that multiplier here, but then we are not like multiplying the noise. So I want to do like an adjust vector. in here, and this is the one that we're going to key. So I'm going to set to manual, and I want this to have like a little bit more in here. So I would like say like that, and then maybe not that much. So yeah, like this. And so up to frame 112, I want to have this. And just before that, I want to decrease that to something less, like zero 0.5. Oh, sorry, zero 0.5, zero 0.2, and zero 0.5. And then maybe before, like between 140, just because I know the frame range. So around this, I want to have like that. And then in here, I also want to reduce again to maybe 0.5 or 0.6, 0.25 and 0.6. And then at the very like 159, it goes up again. You need, if you're using exactly same numbers as I am, then it matches for you. Otherwise, you can just look to your scene and just visualize what's going on. The simulation for the splash itself doesn't take too long, so it's good for you to iterate and to see what works for you. So I'm going to go again, 1.4. What I'm doing here is in each different vector, I'm changing it because I want the X and the Z to be bigger, so it splashes away, and just a little bit on this. And the reason why is because in the first point velocity that we have, I already have a very strong velocity Y, velocity up. So it's just multiplying on top of all that. So just to recap, we have just initial velocity up without any velocity coming in because I deleted the attribute velocity. Then we're taking the normals of the boat and putting that into the norm and the velocities of the points, taking into account that if the velocity is going down, we're not adding that, we're not setting it down, we are just setting 0 on the Y and just keep the X and the Z. And then this one is just for the noise, and this one is just to multiply and control the amount of power onto these points. That's really good. We can just do like a file cache again and cache this out so it reads fast. Let me just see that, and then yeah, we cache this out. And let's set you can first like you can cache this, but before I want to also go into our DOP network and create our DOP network. Let's create a new here. Let's call this out splash emit. Right. I want to plug this into the first input and add splashes sim. Right. This one can start on frame 72. And I will disable now so I can build it. We have a flip object. This first splash I'm going to use as a flip solver. Flip solver. The object initial data, we don't want anything on the initial data. For that, because it's just a splash, I want to give it like a lot of resolution. But yeah, go with something that is more resolution than your regular flip sim. But maybe 0.01 might be too small and high res for you, like depending on your machine. So just do like something like, if you did your main sim at 0.06, do 0.03, something like that in here. All that we can keep as is. And Yeah. So now we need to source the points, right? Like, so we can use like a point source, a pop source, sorry, pop source. Yeah, this one, and we can use in the particle velocities. It's good. It works even if you do like in the post solve or in the particle velocity. It also going to work properly. So we want all points. We want from the first input because we plug this in here. Awesome. So for the birth, I also want to do the negative jitter. So just to break up a little bit and just a little bit of add to inherit velocity like 0 0.2, 0 0.2, 0 0.2, just to give a little bit of variation in here. Let's do a mask by age. So if you do like a geometry VOP, it's the same thing as a pop-up. So we can say like mask by age. And what we can do here, we can fit range the age between like 18 divided by 24, so it's less than a second, like 0.75. And I want to give at least a little bit. And so when the age is 0, so there is no age, the particle is just like born, we're going to have like a mask of 0.1. But as soon as it reaches full age, like, or at least not full age, but like a little bit less than a second, it's going to get like 1. And the reason why is I want the particles to fly with the initial velocity, but then they get picked up by the wind and the wind blow them away. So that's why we're creating this mask. I'm going to bind export, and we can bind export this mask age, or age mask is better. You can copy this one and go back one level. Let's do the pop advect by volumes. We're going to bring the wind force here again. So let's bring the wind force. Is wind force. Yeah, this one's great. We don't want to treat as wind. We want to update the force, and we want to multiply that by 2. And here is where we can use the Vex expression, and you can like pass through. So for that, what we want is the force scale, and the force scale parameter is the first one. So I can delete everything. So okay, the force scale, but we want to multiply itself because we want the force scale of 2 to be multiplied by our mask. So at age mask, right? So what is this is doing for us is, remember that the mask is going from 0 to 1. So it's going to multiply this force scale by 0 when the particle just born. And after the particle is almost like 18 frames, it's going to have like the full effect of the wind force that we have set. So that's what we're doing. And also we can do like the point drag, pop drag. I don't know why I'm saying like point is pop drag. Okay, the pop drag 0.01. I want to also use that random ID that we created, and something like that. It's good. Like maybe we multiply even more, like 0.6 1.2 from that. Great. And I want to delete the particles that are inside our ocean. So we can do a delete inside operation. Like the best way to do that, if we do a geometry VOP, we can just, let me just think. Yeah, we can maybe do like in the post sort and delete inside. Okay, what we want from that? What we want is more or less this, but I don't want to delete exactly in the surface. Yeah, let's do like that. So what we're going to do, we're going to do the same extrude volume thing here, but I don't want to flat the base, and I want this to be like just a meter, and you're going to see what it's going to do. So we have like this thick area, and we want to do a VDB from polygons. This one can be like, you don't need a lot of resolution for that. Yeah, just like that. And I want to erode that, so I'm going to do a VDB reshape, because every time the particle enters this area, I want them to be deleted just to make it more optimized. So erode, and maybe erode by 2. So yeah, and then I can place like an out. You can cache this out, but I want for now out custom surface. Now we select, and this is going to be our input number 1. Let's just select this. So inside the geometry node, I'm going to just bring this guy in, and we're going to have like, so when we dive inside, the output 1 would be this guy, because we pointed that out. So let me grab like, so we're going to do a volume sample. The volume sample allows us to get like the volume inside this. So I'm going to plug this in here and the position. And the STF, it like everything that is 0 is on the surface of the volume. Everything that is negative is inside the volume, and positive is outside the volume. So what we want to do, we want to compare that the volume sample, everything that is less than 0, so is under the surface, I want to remove. So CG remove points. Yeah, we're going to remove everything that is inside the surface. Okay, and that's going to be the post solve. Also for this one, we need the collision. So I will bring the boat. I don't think we actually need to have the sails in this one, because the splashes are going to be basically just colliding with the boat. So I'm going to do a merge, to plug the merge in here, and also maybe we can just copy from where else. That, where do we have it? I think we have it in here, right? No, not this one. Maybe this one. Yeah, we have here. We can bring both of them if you like, but no, the sails no, because in this case the sails are not in the correct position anyway, so we don't need to bring it in. I'm just copying the boat and paste it in here. The boat go here, Shift R just to shift. Particle separation is good. Okay, so we need to set like now our flip itself. I want the flip, I want to add the ID attribute. I want to age the particles. If you don't age the particles, you're not able to use the mask by age. So it's important to age the particles in here. And also here, yeah, it's okay. So let's age the particles. Receding, we can keep receding. Volume motion, we need to define an area for that. I think we can copy the volume motion from, yeah, maybe from the same area here, or no, maybe what we can do, we can just grab the boat itself. Let me just do that. So Let me do like a bound. So we're taking the boat, but I want to increase that drastically to the sides and to every area. So I'm going to increase 5 to one side and 5 to the, maybe to the back even more. Here a little bit, but to the back I want a lot because the particles are going to fly a lot. So this is going to be the limits. I'm going to do like 26, and here maybe 5, here 5. Below I don't want to increase, but up I want to go like 5. So we have like this bound. I'm going to do like a null. Call this outbound boat. So we know that we have here. And then we dive inside. I'm going to put to manual because I'm going to do the same trick that we did. Going to do the reference scene data. Then we are into the FG whitewater. Outbound boat is this one. Bounding box. Size. Do we have droplets on? Yeah, we might detect droplets. It's okay. We don't need vorticity for this one, and it's all good. So then it's all about caching. And let me go to 72. And you can see that this is the bound of the boat and the box center. So now we have everything set for us. And the usual .io. Flip object. We can just bring the particles. We don't care about the surface field, and we are not going to compress it. So we just want the particles for this one. And again, we can do the attribute. Let's see if we can grab the attribute delete from another part. Yeah, maybe these guys. So here, yeah, we don't have this. We do have ID, we do have age, p scale, and we don't have spray. Awesome. Group, awesome. And the name, let's give it a name. All right, so now you just need to cache it, and that's it. So you need to cache both of them. So you can set those up into the tops as we did before. And from that, you just run these simulations. And when we get back, we're going to do additional white water on top of this one. Thank you. All right, so here is my simulation for the splashes. It's really good. You can see, let's pick up an area. You can see that the splashes kicking forward, and then the wind drag them backwards. That's exactly what we want. So you see the splashes, and then once the wind kicks in, after 18 frames, it just blows backward. My idea for the P scale is get the density of that, and points that are flying very very solo, like as less dense areas, get like smaller P scale, and areas that are clumped together, we give a bigger P scale. So and also I want them to fade by the age. So once they start to get like in the back, they also get smaller. So let's implement that with a point swap. Great. P scale by density and age. Let's dive inside. And let me get a little bit more room here. So we need to do the PC open again. So we're going to do the PC open from ourselves, so is input number 1, and also we grab the position. Let's place a PC num found, attach to here, and then we get like a constant for that and a fit range. We did that before, so I'm just going forward a little bit faster. Maximum number of points, and let's visualize that in the color. We can see now what we have. So I want the max number of points to be 50, and we can keep the default radius to 1. So this area is dense, and that's all good. So now I want to also multiply the age of the particles. So let me get like age, and let's fit range the age with like I don't know, let's invert that. So I don't want to have like 0, so I want to always have at least something. So let's see in the color. Yeah, something like that. You see, we don't multiply, maybe a little bit here in this area, and then it fades off. So this is going to multiply everything by 0.3. And now we can do like a multiply. We multiply that. And let's do another fit range, because we want to define two things. One is let's do 2 of those. One is going to be, we're also going to multiply this twice. So I want to multiply like that and like that. The reason why is because one of them is our density. So we're going to bind export density. That is nothing to do with this density that we're defining. Yeah, it actually does do, but it's the idea is because if we render them as volume or white water, it's important to have the density attribute. And also this one is the p scale, right? Like, so let me just plug this in. P scale. All right, so for the p scale, what we're going to have, like, it's 0 to 1 becomes 0.002 and 0.0085. So these areas get like much bigger, and these ones just a little bit. And then for the density itself, we can just do like 1 and 3. So these areas get 3 times more density than everything else. Right, so now we have density, we have the p scale. We can start creating something, because what I want to do now, let's first visualize that. So yeah, you see, it's really nice. This splash is going to give a lot of very rich detail around the boat. But what I think we will need, if we look from the camera perspective, and if I enable show all, I think I'm extruding, I'm reading the wrong object here. I don't want to have this one read, like this one, and instead I want this one. So yeah, let's go to frame, I don't know, like 10 or maybe 20. Yeah, this one. And let's check. Yeah, you see, this is really nice and looks very natural, and connects a lot the boat with the flip. But what I want is another layer of real white water from that, like so. But to create white water, we need a surface field, as you know, and also a velocity field. But we don't have that because we didn't enable that. And the reason why we didn't enable here these two fields is because the field that we get from that is very low res, and we need something a little bit better to portray that. So I'm going to create one for us. So let's create these fields that we need. We need the velocity and the surface field, right? So for the first surface field, we need an SDF. Like so, let's do a VGB from polygons, right? Let me connect this. It takes into account the p scale, so it's good if you do that after the p scale. And here I'm going to go with 0.2. VGB. Oh, sorry, I'm using the wrong one. It's VGB from particles, right? Like so. Yeah. Sorry for my mistake. Yeah. So here 0.2, 0.02. The point radius scale I want a little bit bigger, so like that is good. And I also want to enable this. If you come in here in the point attributes, you can make velocity field, and we call this vel. And we also, it's good if you select this type of vector type for there is the velocity acceleration type. Yeah. So now we have, you can see here, we have the velocity field and we have the VGB from particles, the SDF, that is the sign distance field. Yeah. And then we split them because I want to treat them a little bit separately because I want to do some post processing to the surfacing. So I'm going to come in here and select the surface. And for the surface, we're going to do a VGB reshape. And let's dilate it, but by 2. And then we're going to do a smooth. Not this one, VGB smooth FGF. And you see we're getting like a very rough one, but we're going to use this one instead. And then we are going to also, I need to bring my custom surface that we created previously. So object merge. Actually, the custom surface. You know why I'm not using the real that we get like from the compress? From the fluid compress of the oceans of the flip sim, you get the surface field, right? And the velocity field. The reason I'm not using those is because we post distort the mesh with the big geometry, and that field is just flat on the it represents the flat surface where we have like the simulated area, and we need this other one, so we need to use a custom one. And the custom one that we're going to use is this one. But instead of having this VGB and this reshape, I'm going to get another one that it doesn't have the reshape on it because I actually want the surface field. So I'm going to create another one a little bit higher res, like, or no, yeah, let's keep like 0.5 is enough. But without the VDB reshape that we have for deleting the particles, that we reshape it inside to delete, instead of we're going to have like this one. So it's custom surface. I'll call this eroded, and this is just the regular one. So I'm going to keep like that. And then let's bring this one in, right? I think this one we also going to have the same thing. We need the attribute, so I'm going to get the point V. I'm also going to call it val, and I'm going to bring this one. So why I'm doing that? Because we're going to get like a whitewater simulation, right? And I want the whitewater to fall into the surface and have like these patterns and the same that you would have with a regular whitewater. So I'm also creating a custom surface and velocity field for the flip sim. So now we have 2 of them. You see this guy? It has also both of them happening. Do we need to have it like very big? No, we just need this very thin area, so it's okay. We have like just a thin area. Let it process, and yeah, you see we have like this. This is a good amount of thickness for each work, and these areas is just like a little bit of the velocity field passive poking through. So now we go also going to do a split, right? And we have the velocity and in one side and this one in the other. So I'm going to do a VDB combine, and we're going to combine these two fields, this one and this one. So we have like this, but we need to do an SDF union. Great. So we have that. So we have like a custom field that it's the combination of the splash and the flip, but the flip is already the distorted one, right? So it's really good. And now let's work with the velocity field. So I'm going to do a VGB combine again. Combine. We have now the velocity field from this one with the velocity field from this one. And this one has a very more resolution, and we don't need a lot of resolution for the velocity field because it's just an idea of the velocity. So instead of getting B to match A, in this case, like this has less resolution than this, instead of this matching this, for the velocity field, I want to inverse. So I'm going to do A match B, and instead of doing the SDF union, because this is regular volume, like a VDBs, a fog VDB, I'm going to just add them together. So now we have like this one, that is the velocities, and this one is the surface. If we merge them both, we got like the custom surface volumes that we need for whitewater simulation. If you middle click, you have the surface and the vel, and they are much better and refined than the other one. Okay, if you think that you don't need a lot of resolution for that, you can come to this stage of the VDV from particles and increase this voxel size and reshape that a little bit. It's very forgiving, so don't worry to get this crazy resolution if it's too heavy. What I'm going to do is to cache this out, because this is going to be heavy to every single frame it process that. I want to have like this cache, so I'm going to do a file cache for the volume. I'm going to call this custom volumes. I'm going to save the correct path that I have, like so is this one, yeah. And I'm going to cache this out. And when we get back, we start building the white water from these splashes. Thank you and see you there.